Okay, so now we're on the back here. This is part 2 of the notes. We are at number 3. Here's a picture. We have two triangles. Given angle M is congruent to angle H and segment MT is congruent to segment TH, prove triangle MAT is congruent to triangle HGT. So if we're trying to prove triangles congruent, then our last reason will be side, 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 sine angle, side, ASA, one of those postulates. But statement 1 is always given, so let's write down what the given information is. Angle M is congruent to angle H. Segment MT is congruent to segment TH. And the reason, it's given. Sometimes you'll see in books or on worksheets, they may write these as 2 steps. I always put all the given information in the first step. Okay, so let's label the picture now. We have angle M is congruent to angle H, and we have MT, so that segment there is congruent to segment TH, that segment. Always label angles with arcs and label side congruents with little tally marks like that. So we have 2 things. We need a third thing. Now notice that we have these 2 segments here cross, and when they cross, they create vertical angles here and here. Now we have to put that in the proof. Anything that gets labeled has to go into the proof. Now I can call this angle T, but then there's a problem because we have 4 angle T's. So I need to say this angle here, I'm going to use 3 letters. MTA, angle MTA is congruent, and then this one here is HTG. The vertex of the angles are at T, so that's always the middle letter. Now, why are we allowed to say those are congruent? What's the reason? Well, vertical angles are always congruent. Vertical angles always congruent. Now, in my proof, I see 3 pieces of congruence. So I think at this point we may be able to say that the triangles are congruent. Let's look at one of them. I'm going to look at triangle MTA. So let's see, what have we labeled here? We have an angle, and then we have the side between them right there. So looking at this, that's ASA. So step 3, statement 3, triangle MAT is congruent to triangle HGT. Why can we say that? Angle, side, angle. And that's it. That's the end of the proof right there. So some of these proofs can be very simple, 3 steps. Sometimes they're going to be more. So we've got one more problem here. This one is a little bit longer, but it's set up a little bit differently. Number 4 says put the statements and the reasons into the correct order. Here's a list of statements, and here's a list of reasons here. And what we're going to do, so I've given you all the information. Unfortunately, the information is not in order. So we're going to write it all in here in the correct order for the statements and the reasons. So, all right, let's see, what do we have here? Here's the picture. You have 2 triangles. Given that segment QR is congruent to segment TS, so QR is the top and TS is the bottom. Given that QR, again the top, is parallel to TS. So parallel is this symbol here, where we put these little arrows on the 2 lines. And what we want to prove is that angle R is congruent to angle T. So angle R is here, angle T is here. So since these are parts, then our last reason is probably going to be CPCDC. And the statement right before this one is probably going to be that the triangles are congruent. So you can kind of think backwards. You can almost kind of work and say, okay, I know what the last 2 statements would be. I know what the last 2 reasons would be, and then kind of work that way. Now down here, statements, we're going to start with given. So if I look at my 2 columns, my choices here, QR is congruent to TS is right there. So segment QR is congruent to segment TS. Let's go ahead and write this beneath segment QR is parallel to segment TS. The reason is given. You'll notice that under reasons we actually have given twice. So we get both of those right there. We'll just do that in one shot. All right, now here's the thing. Right now they gave us two pieces of information, but only one piece of congruence. To say that the triangles are congruent, we need three pieces. Now there are actually a couple ways that you can go with this. One thing that I always look for is I look for that common side right there. So segment QS is a common side. I'm going to mark that. Now the way we're going to write that, look in your statements here. QS is congruent to QS. So segment QS is congruent to itself. The reason is reflexive property. So the reason for number 2 is reflexive. Okay, so now we have two pieces of congruence. We need one more. Now they told us that these lines were also parallel. The top and the bottom segments are parallel. Now that does not mean congruent. However, it does mean that some of the angles will be congruent. If I trace these right here, look at that letter Z. It's a backwards letter Z. When the lines are parallel, the alternate interior angles are always congruent. When the lines are parallel, that Z shape creates two congruent angles, whether it's backwards Z or a regular Z. Now, those two angles, if you look at your choices here, angle R and angle T, well, that's my proof statement. That's the last thing. So here's angle RQS. RQS, that's this angle right here, is congruent to angle TSQ. TSQ is this angle here. That's what we want. So right here, angle RQS is congruent to angle TSQ. Okay, now why are we allowed to say that? Well, if the lines are parallel, the alternate interior angles are congruent. Now I'm going to abbreviate that a little bit. I'm going to say parallel lines implies alternate interior angles congruent. Okay, that's just an easier way to write that out. So we have now 1, 2, we have 3 pieces of congruence. So now it looks like we can say that the triangles are congruent. So if we look at, let's take this triangle here in the bottom. Actually, I'll draw it out down here. Okay, so what we've labeled so far, we have, that was the common side, that was given to us, and then we said this angle. So what we have here, this is a side, and the angle between them. If I trace out the two sides, notice that where they meet is that angle. So that's SAS, that's the reason. So we're going to write down here that the triangles are congruent, so that's the top statement, triangle QRS. So triangle QRS is congruent to triangle STQ. Why? Side angle side. Okay, which is this reason here. And now the last thing, if the triangles are congruent, then the parts have to be congruent. So angle R is congruent to angle T. Why are we allowed to say that? Because corresponding parts of congruent triangles are congruent. Okay, so angle R is congruent to angle T, and the reason is CPCTC. So you have to show, if you're trying to show that the parts are congruent, you have to first state that the triangles are congruent. To state the triangles are congruent, we need to have 3 sets of sides or angles, some combination, to be able to do that. Okay, so as you go through, look at what you have and ask yourself, what do I need? What can I get from the picture? What else can I say? Can I say that these angles have to be congruent? can I say that this common side has to be equal to itself? And what happens is the proof kind of works itself out for you. And that is the end of the notes.